So let's talk about the exponential function. What is an exponential function? So fx is equal to a to the power x. This is an exponential function. But here a must be greater than 0. Alright? And a is not equal to 1. So if it is equal to 1, then fx is all fx becomes a constant function and we are not interested in this. Alright? And if we do a is less than 0, then let's say if we have power to 1 by 2, then the it becomes undefined. Okay, so here a is greater than 0 and a is not equal to 1. So what about x? So x belongs to the real line. All right, so x is not equal to 0. Okay, and if we see the uh, x is not equal to 0 and it's also not equal to 1. Sorry, we are talking about a. So this is a, basically a. So let's graph the exponential function. So there are two cases basically. When a is greater than 1, all right, and when a is between 0 and 1. So first let's see a is greater than 1. Then the graph will be something like this. All right, and this is basically a is y is equal to a. So we know that when a x is equal to 0, so then y becomes 1. So this is basically 0, 1. This is the point, right? And this, so, and this is what we call the horizontal asymptote. Horizontal asymptote is x is equal to 0, because along this line that it converges, right? It never touches x is equal to 0, but it converges to this point. So this is called horizontal asymptote. So this is the graph of the exponential function when a is greater than 1. So but what if when the a is between 0 and 1? Then the graph will look something like this. Alright, again this is the point 0, 1. Again the horizontal asymptote is the x is equal to 0. This is the horizontal asymptote, and if we see here in this, when x tends to infinity, when x is increasing, y tends to infinity, right? And when x tends to minus infinity, that is when x is moving this direction, y tends to 0. Y tends to 0, right? And so here when x tends to infinity, so x is moving direction, y is moving towards the 0. Okay, because if we, let's say if a is 1 by 2 and the power is, let's say, 500, so it's basically moving towards the 0, right? And when x is minus infinity, so if x moving towards, you can see that y is moving towards the infinity. All right, so these are the two graphs that you must know of the exponential function. Alright, two graphs are simple. This, and if you just change it, right? And these are the mirror images. Why? So why these are the so basically these are the basically mirror images. Here it is x, a is uh, greater than a, let's say 0, 1, and here the a is greater than 1. So these are mirror images because let's say a, this is x, and this is basically let's, and here is a greater than 1, so, and this is a x. Now this basically becomes a minus, all right? And when you just change this x to minus x, it mirrors along the x-axis, mirror along the y-axis, because the x part becomes the y part, all right? So this is the graphing of the exponential function. And there is one important point to note here is that the range of the function is from 0 to infinity. Okay, from 0 to infinity. It does not touch 0. Okay, so 0 to infinity, that is the range. So the whole way, and 0 is not touched. So this is the range of this function, of both the function. Well, the function in both the cases, when a is between 0 and 1, and when a is greater than 1. And this is a continuous this is a basically increasing function. As the value of x is increasing, the value of y is increasing, and here as the value of x is increasing, the value of y is decreasing. So this is a decreasing function and this is an increasing function, so that's why they are one to one functions. Okay, so yeah, another point, fx is equal to a to the power x is an increasing, oh sorry, it's a one to one function, right? So an exponential function is a one to one function, and it is also reversible.